Today we have our first practice. On this lesson, we will try to solve some exercises, and I hope it will help us to understand better theory material that we have learned before. Okay, and we will need PDF files. With exercises. I have sent this to you in Telegram. And now we need the first part. Mechanics or mechanical basics of multimedia systems. And from that PDF, we need exercise number 2. Exercise number 2. Exercise number 2. From PDF file with mechanical exercises. According to this exercise, during time tau, according to the condition, during time tau, a point traversed a half of a circle of radius r. Find in first part, we have to find the average value of modulus of velocity. The average value of modulus of velocity. The average value of modulus of velocity. This is part A. And I will draw a picture. For this exercise. This is exercise number 2, part A. Part A. These are coordinate axes, X and Y. O, the beginning of or origin of this reference system, and it is said that point traversed a half of a circle. So I will try to draw this half of a circle. Half of a circle. And draw this half of a circle here. This is trajectory, and now I have to remove lower half of this circle. So this is trajectory. This is trajectory of the point. And what do we need? We need to find average value of modulus of velocity. maybe you have some ideas how to do this. And because if you have ideas, you will obtain some some bonus for this. So if you have ideas, it is very well. So don't hesitate to tell them. Okay. Module first part. The average value of modulus of velocity. Uh, this is the whole path divided by whole time of motion. Whole path divided by whole time of motion. So it can be signed in this way. It can be signed in this way, and this is whole path divided by all time. Okay, and the next question is what do we need to use? What do we need to use instead of s, and instead of t? So we need to find these values. Okay, do you have any ideas how to find them? No ideas. Okay. Okay. So let's try to understand the situation. Uh, the whole path is a half of the circle according to the condition. So the path of material point is here. The path of material point is here. So this is our S. Okay, and can you remember? Can you remember how to calculate this S? The length of a half of a circle. How to calculate this?
2PR.
It is PR. Yes, yes, that's correct. That's correct. It will be PR because the whole circle is 2 PR and the half of a circle is PR. Okay. Okay, this is PR. And what about time?
The time must be X. I mean, X must be R.
It cannot be R because R is radius, but we need time.
Time.
We need time in this situation. Okay, let's have a look at the condition. At the condition, I think you have these conditions in Telegram. I have sent them. So you can have a look and you can read the condition. The condition for exercise number 2. For exercise number 2. And you can see that during time tau. This during time tau. So tau is time. Tau is time. So this is tau. So this is the answer for the first part of the exercise. Okay, next part. The condition is the same, but we have to find the modulus of average vector of velocity. Modulus of average vector of velocity. I'll use the same picture. I'll use the same picture. I don't need to draw it again. This is part B. And here we have to find the modulus of average vector of velocity. In previous part we have found average modulus, and now we have to find average vector. Okay, so how to find this? Can you remember the formula for average vector of velocity? It can be signed as this, and we have learned this on our lectures on previous week. It will be displacement vector. Displacement vector divided by time. Divided by time. Dt by ds. But there is two special. It is necessary to notice that not dt by not delta t by delta s, but it is necessary to write this in such way, delta s. But this is it was calculated here. But now we need vector value. Now we need vector value, so we have to use this formula. Now we have to use this formula. And another question is how to define displacement vector. Displacement vector. We know from previous part that that delta t is the same as t in our situation, and this is the same as tau. This is the same as tau. So the next question is how to define delta r, displacement vector. displacement vector. Displacement vector, I'll remind, this displacement vector begins at initial point and ends in final point. Ends in final point. So we have to connect. We have to connect initial and final position. Initial and final position of material point. Okay, and what is initial position? What is initial position? Can you show this on the picture? Initial position of material point. Initial position, the position where the motion began. Yeah, this is yeah, the motion was something like this. Okay. Okay. So the displacement vector is here. This is displacement vector. Displacement vector delta r. Delta r. Delta r. Wait, no. Delta r. Maybe it is better to write this here. Delta r. Delta r. Okay, and we need now we need to write this with formula. To write this with formula. And I mean that we need to write a displacement vector with its coordinates. With its coordinates, or we need to write this analytically. To do this, we may notice that this distance is equal to double r, because the diameter is equal to two radiuses. Okay, and from this picture, can we find this displacement vector? Okay, maybe it is necessary to remind that that if we have two-dimensional coordinate system, Cartesian coordinate system, x, y, here we have origin, and let's imagine that we have some vector a, and we can put perpendiculars here. We can put perpendiculars here, and according to this picture, we can measure this length, this and this, and these lengths this will be modulus of ax, and this will be modulus of ay. This will be modulus of ay. Okay, and according to this picture, a is equal to the direction is opposed to x-axis, so it will be minus ax minus ax minus modulus ax minus modulus axi plus modulus ay yod. Okay, do you understand this?
Yes, it's okay.
Okay, that's great. Or we can write this in this way: axi plus ay yod. And ax less than 0, ay more than 0. Okay, and in such way, we have to draw. We have to find delta r in similar way. In similar way that was shown here on this picture.
It must be like, let me draw somewhere, sir.
Okay.
Uh, what is the symbol between them, sir? I really don't get it.
Symbol, this is a with lower index x.
No, I understand the between, like in here.
Here. It is now I will, okay, I will show this. This is ort or unit vector. We can draw this. We can draw this here. We can draw this here on our picture. We can draw this here, and this will be E, and this will be yod.
Okay. Just a second.
These vectors define directions of coordinate axis, and modulus of I equal to modulus of yod, and this is equal to 1. Okay, that's great, but we need to find this ax, ay.
Okay, AY is 0
Yes,
and AX must be 2R.
2r. Okay,
R.
that's great.
And should I show the symbol again?
I have understood. This idea. Yes, that's correct. So we have found that this is equal to 2r multiplied by I. Multiplied by I. Yes, so we have found a displacement vector. Displacement vector is a vector that connects initial and final position of material point. So we can write that this is equal to r I divided by tau. So this is average vector of velocity. And how to find modulus of this average vector? Modulus, because according to the condition, we have to find modulus. Modulus of average velocity. So we need to find modulus modulus of this vector. Modulus of this vector. So we have to find 2r e divided by tau. Okay, and how to find this? Okay, let's have a look again and on our picture. The modulus of vector is equal to its length. And according to this picture, we can see that here we have the right triangle. And for such triangle, we can use Pythagoras theorem. So we can write that this is equal to modulus of vector A, and this is equal to ax to the power of 2 plus ay to the power of 2 to the power of 2. To the power of 2. And in a three-dimensional case, we will have very similar formula, but it will contain one more coordinate. So plus a z to the power of 2 in three-dimensional case. So something like this we have to use here. Something like this we have to use here. So this is a formula for modulus of vector. So we need to use this here. I'll remind that a is equal to axi plus A Y dot and plus A Z K. K. K is also K is also unit vector that defines the direction of axis Z. Okay, so how to use this here? Okay, maybe it will be better to rewrite this. We can rewrite this in such way: 2 ri divided by tau plus 0 multiplied by yod plus 0 multiplied by k. Okay, does it help with understanding?
So what is tau value in this example? Is it 2R?
Tau is time.
Okay, time, but how we can find the time?
It is known from the condition.
Okay, and then the answer must be like a 0, 0 is the same.
0, 0 because the direction of delta r is the same as the direction of axis x. And of course, this and this is the same. Okay, maybe I will write this. Or I will rewrite this formula in next way. I will rewrite this formula in next way. So we can write this modulus like this. Okay, so can now we use this here?
Of course, we can use it.
We can. And what will we have from this?
2R like jota divided by tau in square, like
Yes, yes,
more,
this is correct. This is correct. We will have square root of sum of squares of squared values according to the Pythagore theorem. Okay, I will write this. Because it is quite specific things, vectors, their moduluses 2r divided by tau squared plus 0 to the power of 2 and plus 0 squared. Plus 0 squared. Yes, and from here we have obtained that this will be equal to modulus of 2r divided by tau, but radius and time are positive values, so we can leave this without any change. Not any change. So this is the answer. This is the answer for second part of exercise number 2. And I remind that this was it was modulus of average vector of velocity. Modulus of average vector of velocity is equal to r divided by tau. To r divided by tau. Modulus of average vector of velocity. Okay, do you have any questions about this?
So in this thing, like we show 3-dimensional, right?
In this case, we need only 2 dimensionals.
Okay, but you show 3-dimension solution, right?
Yes, I used a 3-dimensional formula, but for 2-dimensional case, we will only have that that this will equal this is equal to 0. For
In
2
any other example, should we show the like a z, or just we need x and u for x and y
we may
for
need only x and y.
okay, okay, so thank you.
Okay, and the last part is part C. Exercise number 2, part C. The most difficult in this exercise. This is the most difficult. This is, but the picture will be similar. The picture will be similar, but it is necessary to improve this. The picture will be similar. Okay, part C. Part C. The condition is almost the same. Time and radius are known from the condition. They are known from the condition. And in this case, we have to find the modulus of average vector of full acceleration if tangential acceleration is constant. Tangential acceleration is constant. So we have one more condition, that tangential acceleration is constant. What is interesting, we don't know tangential acceleration, but we know that this is constant. So it doesn't change in time. It doesn't change in time. So we need to find average acceleration. Average acceleration. Okay, and how can we write this? The formula will be similar to this. Formula will be similar to this. I will rewrite this here. as you can remember, for average velocity, we used such formula. And what about average acceleration? What about average acceleration? Okay, the situation will be similar. Similar because velocity is a change of position, and acceleration is change of velocity. So we can write very similar formula in this way. Very similar formula. Okay, and now we need to find delta v, change of velocity. Change of velocity. From the condition, we know that delta t is equal to tau. Delta t is equal to tau. Delta t is equal to tau, and how to find delta v? I think we can write this as a difference between final velocity and initial velocity. Final and initial velocity, delta t. Delta t. The difference between final and initial velocity. Okay, and the next step is to show this final and initial velocities on our picture. Okay, and how can we do this? How can we show these velocities on our picture? Maybe you have some ideas how to do this. Okay, velocity is always tangential to trajectory. Trajectory is the half of a circle. So velocity must be tangential to this half of a circle. And it means that at the initial point, velocity will be here, v1. Okay, and what about final point? What about final point? Do you have some ideas how to show vector of velocity in this case, in final point?
Maybe something like this.
No, no. The velocity always directed in tangentially to the trajectory. Trajectory is half of a circle.
It's here. Half of the circle is here.
Half of a circle is this half of a circle.
Ah,
This is trajectory of motion. And we need to find a vector v2 in the same way as we have done this for vector v1.
so V1, it's maybe V2. Final point is here.
Final point is this. This is final point. Oh, and here we need to draw vector v2 to define this vector.
Okay, let's say the final point is here.
Final point is here, yes.
And like it must be some like here, like this to right, I think.
No, no, the direction of velocity is always the direction of motion. It means that for example, for this point we have this direction, and here we have this direction. Okay, and what about final point?
For final point, direction like here.
Yes, 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 that's correct. That's correct. This is vector v2. Okay, okay, this is vector v2. This vector v2, and now the next step is to write these vectors v1 and v2 in this form. It is necessary to write this in such form. In such form. Okay, so how to do this?
So if you want, I can try to write it.
Okay,
For V1, we like Ix must be 0 in V1,
yes,
and uh, Ay must be like R. So am I right? Like,
no, it is not r. It will be it will be uh, it will be modulus of v1. It will
okay,
because the direction of v1 is the same as y, and it can be written in simple way like this, without arrow,
okay.
above a vector. And here we can Okay.
But I must add like Jota and
Yes, yes. Okay, and here we have, and it can be written in simple way, V1 multiplied by yod. Because without yod, we will have, this is vector, but this is scalar, and vector cannot be equal to scalar. Because vector and scalar are different types of value. Different types of value. It's similar like for example integer or array of integers.
okay.
It's from data structure. Because integer and array of integers are different, and a similar situation with scalar and vector. So vector cannot be equal to scalar. Okay, so from here we can, okay, this is correct. This is correct for V1. And what about V2?
V2, okay, I will try to do V2.
No, why to R? It is not correct
AX, it's
because the direction of V2 is here. This is direction.
and the AX should be like 2R in here, so
AX will be 0 for V2 because delta R is a blue vector. Delta R is equal to double R E. Double R E. Because the direction is from left to the right. But for V2, the direction is from up to down.
you mean this is a new, like we ignored this vector? We ignoring it, or
We will ignore this because this is displacement, but now we need velocity.
okay,
These are different vectors.
okay.
0 multiplied by E. And what about second component?
V1 is mm, a Y is it's still zero, sir, or we just wanna like do the like this value?
Like this, similar way.
If it's similar way, we're gonna say it's V1 again.
Not V1, V2.
Sorry.
Because now we are speaking about V2. And
Mhm.
what is necessary to take into account to take into account that the directions of axis y and v2 are different. So we have situation. We have this situation, and it means that we have to change sign. We have to write minus in
Uh,
front of
for
v2,
for all sign or just for the sign?
just for v2.
Okay.
Because if we have zero, there is no difference if it is minus zero or plus zero, uh, because it may have sense in calculus. It may have sense in calculus, but in this situation,
Like you mean if the direction of V2 was like this thing, and the sign is here must be plus. If
yes, yes,
go down, it must be minus.
yes.
Okay, I got you. So
Okay, and the situation is similar to what was shown here. Here we can see that that ax is less than zero and ay is more than zero. Why? Because the direction of vector a, is opposed to the x. So we can write that vector a has direction the direction, and vector a has the same direction as axis y, and because of this we have this and this. So this is about signs of components of vector. Okay, and as we have these vectors, we can use them. We can use them here. We can use them here to find this average acceleration. So minus v2 yacht minus v1 yacht, and divided by tau. And this will be minus v2 plus v1 divided by tau. Okay, we have found something, but it's still not the answer. It is not the answer because we don't know anything about v2 and v1. We know only tau. And but in this case we have one more condition. A tau is equal to const. And the question is how to use this condition. how to use this condition to to find a connection between V2 and V1. Okay, we need to remember one more formula from our theory that we learned on previous week, and we can remember that tangential acceleration a tau is equal to first derivative
单纯的我们打野我不明白而已。单纯的我们打野我不明白。
Oh, I cannot hear your question because something with sound.
Question, sorry, I think it forgot turn off his microphone.
Don't understand.
I said it wasn't question.
Ah,
I
it
think
was
he's forgot to turn off his
his microphone. Okay, okay. I understand. I understand. It happens sometimes. It happens sometimes. But because yes. So it is necessary to turn off your microphones if you don't want to say or ask something about our lesson, because it may prevent us from studying. Okay, so we can remember this formula, and from here we have to get dependence of velocity on time. So how can we get velocity from this formula? How can we get velocity from here? As you can remember from calculus or mathematical analysis, this is a differential equation, simple differential equation, and if we solve this, we will get v as a function of time. V as a function of time, and to solve differential equation, we have to integrate this. But before integration, it is necessary to separate variables. Sometimes we can do this. But sometimes not. In this case, we can separate variables. To separate variables, we have to do two things. The first thing is that v and t must be in different parts of equations, and there should not be differentials in denominators. So how to meet to these conditions? We can multiple two parts of equation by dt. So from here we will obtain dv is equal to a tau dt. dt. So this simple transformation, but here variables are separated. Variables are separated. Why? Because v is in left part, and t is in right part of equation, and there are no differentials in denominators. So this equation can be integrated. This can be integrated, so we can rewrite this. We can rewrite this in the next way. We can rewrite this in the next way. Okay, do you understand this?
Yes.
Okay, and the next step is to set integral limits. To set integral limits. Let use the initial time. Let set initial time as 0. Initial velocity was v1, and at moment in time t, we have velocity v. And we also need to change our signation. I will draw such thing above letter in order to make different signations here and here, because there cannot be the same letters in integral limits and in integral function. Okay, and the next step is to calculate these integrals. Okay, and what about this? What about this? Can you remember from calculus how to calculate this? How to find this defined integral?
Like first calculate in this value and then calculate this value, and it's like minus
Yeah,
this value and this one.
yeah. So we can write this. It will be v minus v1. V minus v1. Okay, is it clear?
Yes, sir.
Oh, okay, that's great. And the second integral. The second integral is integral from the right part. And now we can use our condition. That a tau is const. A tau is const. And from calculus, constant may be written outside of the integral. So we can write that this is equal to integral from 0 to t dt. And so we have a tau multiplied by t. Multiplied by t. So we can use this here and here, and we have obtained v minus v1 is equal to a tau t. A tau t. And from here we have v is equal to v1 plus a tau t. A tau t. Okay, so we have obtained connection between v1 and v1 and v, and as we can remember from condition, the whole time is equal to tau, so v2 is equal to v when time is equal to tau, and it means that v2 equal to tau instead of t. And after substitution, we will obtain that this is equal to minus 2v1 plus 2v1 plus a tau divided by tau, and here we have yod. Here we have yod. Okay, and this is, yes, this is the modulus, no, not modulus. This is average acceleration, and I think we can write its modulus. We can write its modulus. So modulus of a is equal to square root of 0 to the power of 2 plus minus 2v1 plus a tau divided by tau to the power of 2 and plus 0 to the power of 2. And this will be equal to modulus of 2v1 plus a tau and divided by tau. And this is the same as 2v1 plus a tau divided by tau. Okay, so but it is still not answered. It is still not answered because we know that tangential acceleration is constant. We also know that and we don't know anything about V1. So what to do in this situation? In this situation, we can remember that V is equal to V1 plus a tau 2. And can you remember from theory the definition of modulus of velocity? The connection between path and velocity. It is first derivative. First derivative. Is first derivative. So from here we can write that ds by dt is equal to it is equal to this. Is equal to this. Okay, and we have differential equation again. We have differential equation again, and can someone remember how to solve this? We have already solved one differential equation before, and how to do it again? The first step is to separate variables. Variables are s and t. So how to separate them? It may be done by multiplying left and right parts of the equation by dt. So ds is equal to v1 plus a tau t and dt. Okay, and can it be integrated? Yes, it can be integrated because variables are separated. Variables are separated. So let's integrate this. Let's integrate this. Let's integrate this. Okay, and what about integral limits? What about integral limits in this situation? I have no ideas. Okay, the situation will be similar as it was here. From 0 to t, from some initial value to a value at a moment on time t. So here from 0 to t, and here from 0 to some s. Okay, and can you calculate these integrals? Can you calculate these integrals? For example, what about this? What about this?
Is it 1? Just 1, sir? So,
y1. We have limits here.
okay, we use as inside the integral.
Mhm.
It give us what?
Maybe you can remember when you can remember table of integrals, and you can find here something like this is equal to x to the power of n plus 1 divided by n plus 1 and plus c. And we can use this here for this integral dx. This is the same as integral of 1 dx. This is the same as x to the power of 0 dx. And so this will be x to the power of 0 plus 1 divided by 0 plus 1 plus c. And this will be x plus c. Okay, so can we use this here in our situation?
Of course, we can use it, but let's try
To use integral limits? Of course, we will use them because we
use
have
like integral for s. This is for s. Like we use s. I mean, let me show you an example. Like here is s is like x power 0 multiplied by 1 dx. Is it for, it's for like you show us in here. This is n for like this example. If we say s, how we can like convert it x in the s inside this example? If you show us, you know, we didn't see any mathematic calculation for a long time, and we didn't see any physical calculation science here. Maybe you can show us and we can do practice later.
yes, of course I will. Of course I will. I understand that that you have learned this 2 years ago. This is a very long time, and
For a long time, we just use like program coding and something like that. We don't use the calculation and other thing. And actually, I forgot all formulas.
okay, it's okay. It's okay. It's normal situation, and of course I will remind this. Of course I will remind this. So according to this formula, we have that this is equal to s with this sign above. So and limits s equal to 0 and s equal to s. So according to this, we have s minus 0, and this is equal to s. This is equal to s. This is the integral in left side. Okay, and what about integral in the right side of the equation? On the right side of the equation, it will be here. Okay, and the integral of sum is equal to sum of integrals. So we have v1 integral from 0 to t dt with this sign, and plus a tau integral from 0 to t t with sign dt. Okay, so here we can write that this is v1 t plus integral limits, t is equal to 0, t is equal to t plus a tau t to the power of 2 divided by 2 integral from t equal to 0, and the t is equal to t. Okay, let's calculate this. So this will be v1 multiplied by t minus 0 plus a tau t in this here it is not so simple. It will be in this way, t to the power of 2 minus 0 to the power of 2, and this is equal to v1 t plus a tau t to the power of 2 divided by 2. Okay, do you understand this?
It's hard, but it's okay. So
Okay, that's great. And because I tried to write this in particular details, and we can use this here, and we will get that s is equal to okay, but we know that according to the condition, s of s at a moment in time that equal to tau. That at this moment in time, half of a circle was passed. Half of a circle was passed. So we can write that this is equal to PR, and from here we can write that this will be here will be tau and from this we can obtain that 2v1 plus a tau to the power of 2, a tau multiplied by tau, and this is equal to 2p r divided by tau. Okay, and do you understand this?
Yeah, so after meeting, can we access the whiteboard or it's just gone?
Okay, and we have almost finished this exercise. We have almost finished. So we have obtained that, and as you can remember, we try to find the modulus of average acceleration. So we can substitute this here, and we will obtain 2p r divided by tau to the power of 2. Okay, this is the answer for the last part of this exercise. This is the answer. Okay, and for that's all for today. And for homework, you may do exercise number 1.
Will we have any Google Classroom?
Classroom, but you have these exercises in your Telegram.
Okay, I know it. If we have a classroom, it will be better, so I think, because it's more like more easy to find files and access the other resources.
But we have only 4 files for this semester, so I don't think it will be very difficult to find them.
Okay, as you wish, sir.
A video of this lesson will be on my YouTube channel. On my YouTube channel, you know this. So, and exercise number 1 is from mechanics. From mechanics is for homework.
Okay.
Maybe if it is very necessary, I can create classroom. I
just ask, sir.
Okay. Okay. Okay, so thank you for your attention. Thank you for your attention, and have a nice day.
Have a nice day.
Yeah, so bye.